This afternoon, I'm joined by Chris Taylor-Hamlin of Neoperl, who also happens to be the BMA's chairperson for taps and shower control on the technical committee. Welcome, Chris.
Hi, Tom. How are you?
I'm good, thank you. Let's get straight into the interview. Why is the bathroom industry, as an industry, so interested in reducing domestic water consumption?
Well, we all know today there's a general sort of understanding of reducing energy use, reaching for net zero, and reducing water consumption fits with this incredibly well. The energy to heat water in particular is significant as a percentage of home energy use. And from an infrastructure point of view, water is heavy to move. So moving less of it has massive infrastructure gains too. All this helps the industry do its part of striving for net zero.
So let's get into some of the specifics of bathroom products. What are the different types of showers that we have here in the UK?
Wow, what an open-ended question. Okay, where do you want to start? I guess for me, the starting point for the UK specifically is electric showers and mixers. That's the obvious separation. However, one can have an instantaneous electric shower or pumped electric shower or even an integrated pump shower and so on. From a mixer point of view, one can have mechanical mixers, thermostatic mixers and digital mixers. The reality is there is a huge range of diversity in the available shower market, with each manufacturer potentially using slightly differing terminology for essentially similar product types. We also have nascent shower markets, in particular with forced air and recirculating showers that are just making their way to the fore. So it's really difficult to say what are the shower types. They're really varied for the UK, and I don't see that situation changing anytime soon.
So lots of different types of shower. We also have various different water pressures in the UK's homes. How can those different water pressures affect the performance of fittings?
Oh, massively, Tom, massively. The biggest generalization here, though, is to say that lower water pressures equates to lower flow rates, but that's not strictly true. However, understanding the water pressure is a key to good product design. There are a number of traditional manufacturers that understand the traditional UK low pressure scenario very well, and as such, maximize flow rates for products designed to be used with low pressures. Typically, then, products designed for high pressure systems have a relatively easier job to control water and are usually able to do more with water than focusing on maximizing the flow rate, such as pulsating or massage sprays and showers. Stands to reason also that as the UK market has both high and low pressure systems, there are also systems in use combining high pressure cold supplies with low pressure tank fed to hot supplies, and this gives rise to specific problems for the UK market that require specific design solutions, such as kitchen taps with divided spout outlets. Manufacturers operating in the UK need to be aware of all possible pressure vagaries and their own strategies to address these when their products are fitted. The solutions can be varied from specific designs for low pressures to recommending high pressure supplies only, or the use of flow regulation high pressure supplies to allow some products to be used on both high and low pressure systems with the additional removal of flow regulators. So it's just massively varied, and it's key to how the manufacturer approaches the market as to what is necessary to design in for their products for the best user experience.
So that sounds very, very complicated. One of the things we see manufacturers talking a lot about through all of this is the flow curve. What is the flow curve, and why is it important as we think about lowering domestic water use?
Okay, so the flow curve is a metric that, as it says, gives the flow rate of the product through the product. Now, from a Neoperl perspective, we supply flow curves for all of our products that we supply to our OEM partners. The flow curves we provide help customers better understand the overall performance of their product when an aerator or flow regulator are to be fitted. The curve details the expected amount of flow rate through our component at a given pressure. This helps manufacturers to design products with a specific flow rate, even with varying supply pressures, while maximizing the experience for the end user. And that maximizing the experience for the end user is really the key aspect here.
One of the things that manufacturers have warned about quite extensively in the past and right up to now is the risk of lowering flow rates too low, and that resulting in a higher water use, which sounds a little odd, but can you explain how that might be the case?
Yeah, there's a number of aspects here, Tom. From showers that have flow rates that are too low that cause end users to take longer showers, just because it takes longer to rinse the soap off. That negates the supposed benefit of low flow rates and then we have low flow rate kitchen taps that infuriate users when they need to fill the kitchen sink. That with the low flow rate just takes too long. I mean, simple things, but they're a constant cause of irritation if that is the thing that irritates you. We've seen situations like this in other countries too, like California in the US, where driving flow rates too low creates massive negative reaction by end users to the low flow rate. Studies have shown that where this happens, users take action to overcome the limit of the flow rate. This can cause significantly higher flow rates from products due to the tampering than if the product had slightly higher flow rates in the first place. So targeting the flow rate for the specific use is absolutely key, that we get this right and we understand this as we move forward with water efficiency as a whole.
So moving forward then to how manufacturers can do that, how are flow rates moderated within a tap or a shower?
Well, I'm going to start right from the basic point here, Tom, and the most obvious point of moderation is that of the control handle. Open it more and one gets more water. We should not forget this, as user behavior is a massive part of water efficiency. The technology that we have available to us is only there to help the end user have a better experience rather than replacing the direct control of the shower of the tap by the end user. In terms of design, there's obviously lots of design options for taps and showers, such as careful use of venturas or careful nozzle design on shower heads, or even limiting the flow path area. All these can moderate flow, but the most commonly used methods for taps and showers are the fitting of aerators. Aerators may be flow regulated or fixed resistance types or simple flow straightening devices. All types have their place in the market. Flow regulators for showers can be fitted to showers and shower heads and are frequently used for this purpose. Ultimately, though, manufacturers are free to use whatever method is most appropriate for their product, but we do find that using flow regulation is often the simplest solution to enable manufacturers to maximize their design potential.
So that's how the flow rate is regulated. If consumers or plumbers are not satisfied with say a low flow rate shower, how might they do something to kind of work around or to interfere with the product, and what are the risks if they do that?
Okay, so we're referring back to the situation in California. We
Yeah.
know from studies there that many end users remove flow regulators where flow rates are perceived as too low. So, this could lead to unintended consequences from the tampering, such as altering how thermostatic controls work, which could cause scalding. There's very likely going to be an increase in water use, and this may be significantly more than regulating products to an appropriate flow rate in the first place. By the same token, plumbers may be moved to tamper too, as they may see the tampering as a way to negate the possibility of a callback from the end user, who may think there is a problem with their tap or shower due to the low flow rate. Ultimately, then, education and greater understanding in the user base will help negate this as a problem, and we need to get the information, the correct information, to end users and to installers why we are flow regulating, whichever method we use to moderate the flow, and what it means and why they shouldn't tamper. Part of that jigsaw puzzle, though, is making sure that the flow rates that we deliver to market are correct for the intended use. And that's really a key part here that we cannot overlook.
So I suspect this could be an interview all of its own, rather than a single question. But what are some of the specific applications that do require a higher flow rate than the standard?
So bath fill is the obvious example here, Tom. One needs to fill the bath as quickly as possible to minimize heat loss in terms of efficient use. However, we also need to be sure that for kitchen tap applications, we have high enough flow rates to vessel fill. And even for basin taps and showers, we need to be sure that we have high enough flow rates to get hot water from our heating systems. For example, if they are supplied from combination boilers. Ultimately, citing high or low flow rates can be a pejorative term, and we need to be able to select the correct flow rate for the intended application. We can't talk blandly about high or low flow rates. We need to respect that the flow rate itself is in relation to an intended activity, such as vessel filling or hand washing. So really careful thought about the terms that we use, in particular when we are talking with specifiers or talking with end users, so that we don't get into this pejorative nature, is a fundamental part of how we as a sector approach this.
One of the things that we talk a lot about within the industry is around functionality, and we want to make sure that whatever happens in policy terms and innovation terms, we keep the functionality of the products. How can this be kind of factored into some of the policy making decisions coming up as government and collectively as an industry, we encourage consumers to adapt to a more water efficient lifestyle and more water efficient fittings?
Okay, so for me, this again, I really need to start with the basics. And in the first place, we should understand the basic function of the product. Without trying to oversimplify this situation, taps and showers are designed to deliver water. This is the basic functionality. Yes, we can also look at spray dispersion, spray force, as well as temperature drop for showers. And yes, these are also part of the functional performance. Having said that, measuring these performance factors is one thing, but trying to say a particular metric is good or bad is something quite different. We really need to be honest with ourselves, as do the regulators. There is simply no point in creating a framework that reports a water saving due to lower flow rates if we get tampering, or if we characterize certain metrics as bad or good. We could be in danger of repeating mistakes such as counting carbon emission reductions for high efficient light bulbs that are really not installed but are sat in a drawer somewhere. So this is something, again, the honesty of the situation when we speak with regulators needs to be but two-sided, and it needs to be really upfront and understood before we put in any sort of regulating framework.
Well, one of the things that the government is considering, following an announcement in the summer, is the introduction of a mandatory water labelling requirement. You're obviously, as well as being chair of the BMA technical committee, you also lead the technical committee of the Unified Water Label Association. What do you see as the advantages of the UK government utilising the existing scheme as they move towards that mandatory labelling requirement?
Time and cost are the most obvious things, Tom. The water label is there, it's ready to be used, which gives a leg up to the industry because we're familiar with it. It gives a leg up to regulators because there's a cost reduction in being able to use it. But in the first instance, the water label is a means to educate consumers and to raise awareness on water saving options. Consumer behaviour is still crucial. Technology can only support the behaviour, and the label is the part of the industry's arsenal to meet any mandatory requirements here. If government listens to industry, the intended mandatory label should be water label without specifying any maximum flow rates for products. This in itself be a major step change for the market, but significantly help in educating end users while giving more information back to the market and regulators should the mandatory position need to be updated. So for me, there's a real logical, simple flow path here, no pun intended, in that we introduce the water label, we see how that works, we get feedback. If we need to change and we need to put some sort of maximum flow rate or backstop in at a later date, we do it with increased information rather than trying to guess at something and ending up with like a California type situation, which is encouraging tampering. That would be a lose-lose all round.
I think you're spot on. The thing that we need to avoid is any perverse outcomes in all of this. But certainly as an industry and individual companies such as yourself, we're all committed to feeding into government and working towards the ultimate ambition, which is reduced domestic water consumption. Chris, I really appreciate your time this afternoon. Thanks very much for joining me, and I'm sure this is the first conversation of many.
You're very welcome, Tom. Good to speak with you.